Lesson 1, Diodes. Section 1.3, Diode characteristic. This is an excerpt of the periodic table of the elements. Group 13, 14, and 15 are listed. These groups are also called group 3, 4, and 5 in Roman numerals respectively. Silicon is the most popular base element of semiconductor devices. Silicon belongs to group 14. Assume that there is a silicon base and a small quantity of a group 13 material, for example indium, is doped in the left part, and that of a group 15 material, such as arsenic, is doped into the right part. Then the left part becomes a p-type semiconductor, and the right part is changed to an n-type one. This metallurgical junction is called p-n junction. This is a diode. This is the symbol of diode. The left side electrode is anode, and the right side one is cathode. This is the result of experiment 1.2, the relationship between the current ID and the voltage VD of diode 1N4118. Fermi-Dirac probability function gives this equation for the relationship between ID and VD, where T is absolute temperature of p-n junction. The unit is Kelvin. K is Boltzmann's constant. The unit is joule per Kelvin. Q is electron charge. The unit is coulomb. And M is empirical constant. M depends on the structure of diode. By using a least squares method, the experimental result can be fitted with this Fermi-Dirac function. The red line is the result of curve fitting. The Fermi-Dirac function approximates the measured one fairly well. The experiment was carried out at room temperature TA equaled 24 degrees Celsius, 297 Kelvin. The junction temperature was assumed to be equal to the room temperature. The coefficient I0 and the empirical constant M were identified by the least squares method. It should be noted that when VD is negative, ID is almost equal to negative I0, and the identified value of I0 was 9.45 microamperes. The absolute value of negative I0 is called the reverse current, denoted by IR. According to the datasheet of 1N4148, the maximum value of reverse current IR equals 25 nanoamperes. My experiment was not accurate enough to measure the reverse current. Experiment 1.3. Pause the video, and follow the instructions. This is the snapshot of the oscilloscope. The orange line is one of the source voltages V1, and the purple line is the voltage across the resistor RL. Only the positive source voltage appeared across RL. Exercise 1.3. This is your homework. Pause the video, and draw the answers. The author of this material is Takeshi Furuhashi, Professor Emeritus, Nagoya University. If you have any questions, send emails to this address.